Intersections of functions. We've actually already done a little bit with intersections of functions back in chapter 1 when we looked at solving some quadratic equations using the calculator. We've got three examples here that I'd like to take a look at. In the first one, we're going to intersect two straight lines. In the second one, we're going to intersect a straight line with a quadratic equation. And in the third one, we're going to intersect two quadratic equations. So let's begin with example 1 and see what we can do here. So we need to put in the two functions into the calculator. F of x equals negative 3/4 x plus 7, and g of x is equal to 4x minus 3. And we'll put those into the y equals menu into y1 and y2 respectively. So I'm going to type negative, and then I'm going to put that fraction in parentheses. Again, just trying to make sure that I don't have any trouble with order of operations here. So open up parentheses, 3 divided by 4, and that's x plus 7. I also think it's easier to read this way as well, putting the fractions in the parentheses like that. So there's f of x, put that in y1. y2, we have 4x minus 3, so I'm going to type in 4x minus 3. The two lines definitely have different slopes. One has slope negative 3/4, the other has slope positive 4, and therefore they will intersect. We know the only time lines don't intersect is when they're parallel, and for that they would have to have exactly the same slope, number and sign, and we definitely don't have that here. So let's just graph this in a standard window. So I'm going to zoom to the standard window and let the calculator graph these two lines. It'll graph them in the order that I entered them in. So this first one is going to be f of x, that is negative 3/4 x plus 7. And the second line, when it starts to graph, will be the y2, or g of x, 4x minus 3. And as you can see on my screen, I have the first graph, and here comes the second graph. Something else we know when we're dealing with just straight lines is they will have at most one point of intersection. Because they are straight lines, they can't curve around and intersect in more than one place. So we can see that intersection clearly in the graph, so we don't really need to adjust the window. We could if we wanted to, but there's no specific or special reason that we need to adjust the window here. So we can go straight to the Calc menu. We press second and the trace key, which has Calc above it in the same color as your second key. And we choose option 5, intersect. We're going to answer three questions. We're going to answer first curve, second curve, and guess. Since we only have two curves, we can just simply press enter for first curve and enter again for second curve. The calculator will automatically jump from one to the other. If we had more curves than that, we would have to make sure that we're choosing the right curves and potentially use the up and down cursor keys to select the proper curve. Then we get our guess, and I'm cursoring. In this case, I needed to cursor to the right to get to about where that intersection is. As close as we can get makes the work for the calculator quicker and easier. And when I have my flashing cursor here close to the intersection, in this case it looks like almost right on it, I'm going to press enter for my guess. And the calculator is going to come back and tell me the intersection is at the point 2.1052632 for x and 5.4210526 for y. Now these are decimals, and we don't see any obviously repeating values here. So we're going to want to see if we can turn those into fractions potentially. So we're going to quit out to the calculator screen. So second and mode to quit to our regular calc screen. And we'll press X, and then we'll press math. Choose option 1, which is convert to a fraction, and press enter. And in this case, we find out that the x-coordinate of the intersection is 40/19. And we can do the same thing to find out what y is. We'll press alpha and 1 to get a y. We'll go into the math menu. We'll choose option 1, convert to fraction, press enter, and we find out that the y-coordinate is 103/19. So our point of intersection for example 1 is the point 40/19, comma 103/19. That's exactly where it lies. In example 2, we're going to consider a linear function and a quadratic function. So we're going to go back into the y equals menu, and we'll clear out our functions from example 1. And then we'll go and put our linear function f of x in for y1. So we'll type in negative 2x plus 3 and press enter. And then we're going to take g of x and put that in for y2. So g of x is negative x squared plus 6x minus 1. And we'll press enter there. So now we have our two equations in here, negative 2x plus 3, negative x squared plus 6x minus 1. Now with a quadratic in a linear, we can have as many as two different points of intersection. So when we look at the graph, we're going to need to be careful and make sure that we find all the points of intersection that may exist. I'm going to zoom to a standard window again for graphing. So I'll choose the zoom menu in option 6. Then the calculator will graph first the linear, or straight line I should say, the linear function, negative 2x plus 3, since that's what we put in y1. And then it will graph the quadratic function g of x, because that's what we put into y2. So you can see on my screen here we have the first function, the linear function, and now we're getting the quadratic function. We have one intersection. And we can't quite see that second intersection. It looks like it's going to be a little bit off the screen, so we should adjust our window. And what I'm going to note here is that to see this first intersection, we don't need to see a lot of the left-hand side of the screen. So x min of maybe negative 2 or negative 3 should give us plenty of room to see that intersection. And we don't necessarily need to see an awful lot above it either. So we could go to say 5 or 6 for y max here. X max though, we probably have enough on X max at 10 right now to be able to see this, but we're going to need to make y min a little smaller, maybe negative 15. Alright, so to summarize there, I'm going to choose about negative 3 to positive 10 for X min and X max. Negative 3 to positive 10, X min to X max, and about negative 15 to positive 5, Y min to Y max. So let's do that, pressing the window key. X min, I just said I'm going to choose about negative 3. X max, I said I'd leave at 10. And I don't think we need to adjust the X scale. You can if you like. Y min, I'm going to extend down to negative 15. And Y max, I'm going to reduce to just 5. We'll graph again in this new window. Here is our straight line, our linear function f. And coming behind it will be our quadratic function g. And we can see that first intersection just fine. We've cut the top off the parabola, but that's fine. All we need to be able to see are the intersections. And we come down here and we see the second intersection. So we can see both intersections just fine. So let's press second and the trace key to get into the calc menu. Choose option number 5, intersect. And I'm going to go for the left-hand intersection. So I'm going to start cursoring back up in that direction to remind myself where I'm at, even before I answer any of the calculator's questions. And I'm just about there at the intersection. That looks pretty good. So since we only have two curves up, I can choose whichever curve the calculator wants for curve 1, and it'll automatically go to the other curve for curve 2, so just enter twice. And then I'll make my guess, and I'm already about at where the intersection is, so I'm just going to press enter and let the calculator work that out. In this case, we get an intersection at 0.535898838 for x and 1.9282032 for y. Let's see if we can convert those to fractions. So we'll press second in mode to quit back to our calculation screen. And I'm going to press X and math. I'm going to choose option 1 to convert to fraction and press enter. And I get the decimal back. And remember that we have a quadratic involved now, so there's a chance that we have irrational numbers involved here. We'll double check the y just in case it'll go to a fraction, but it's unlikely once the x didn't convert to a fraction. So I'll press alpha and 1 to get the y, then math, choose option 1, convert to fraction, and press enter, and neither one did. If you needed an exact answer for this problem, you would have to go to pencil and paper and use those types of methods to find the exact coordinates of that intersection. If an approximation is okay, then you have it here. You can round both of these answers to however many decimal places is deemed appropriate. If we go back to a picture of a graph, we see that there also is a second intersection, and if you're interested in finding that, I will leave that up to you to do. I would like to move on to example 3 and look at an intersection of two different quadratic equations. So I'm going to press y equals, and I'm going to turn off these two graphs since I left that second intersection to you. Instead of clearing those out so you might potentially have to enter them again later, we'll just turn them off. And we'll use y3 and y4 for our f and our g respectively in example 3. So I'm going to enter x squared minus 4, that's our f function, into y3, and press enter. And then I'm going to put g of x into y4. So in that case I have to enter negative x squared plus 9. And then I'll press enter. And those are our two functions in y3 and y4 in this case. Again, we've got four functions here, but because we've turned off the first two for graphing purposes, they'll remain, but their graphs won't show up. So I'm going to go back to the standard window. So I'm going to press zoom and option 6 for standard and see what this graph looks like. The calculator will first graph x squared minus 4, and you can see it coming up on my screen right here. Then the calculator will graph negative x squared plus 9, and that should begin coming up here in just a moment. There it is. And we can see both intersections very clearly. You shouldn't have more than two intersections with quadratic equations. So let's find the intersection on the right, and I'll once again leave the one on the left to you. So we're going to press the second key and the trace key to get into the calc menu. Choose option 5, intersection. And once again, before I answer any questions, I'm going to cursor over to the intersection that I'm interested in. That way I kind of won't forget which one I've chosen to look at. I said the one on the right in the first quadrant here. So I'm going to go to about where my guess would be. And then it's asking first curve, and I'm currently on y3. That's okay. Calculator wants second curve, and it's just moved to y4. That's fine. And it wants a guess, and I'm awfully close to the intersection, so that should be a good guess. So I'll press enter, and we get an intersection at 2.5495098 and 2.5 for the y coordinate. 2.5 is 5 halves. We can write that easily as a fraction. Very easy to write that exactly. We'll have to see what we can do with the x. So we'll press second in mode to quit back to the calculator screen, and we'll press the x variable key, and then we'll press math. We'll choose option 1 to convert to a fraction, and we'll press enter. And in this case the calculator is not able to convert that back. There's a slight chance that it's just too complex of a fraction, but it's much more likely that means that the x coordinate has a radical left in it, a square root of some sort. That is that we have an irrational number here. So if you needed that exact coordinate, x coordinate, again, you would need to go to paper and pencil and use methods there. If an approximation is okay, you can round this to as many decimal points as you want, and we can remember that y was 2.5 or 5 halves. So that's pretty easy. If you forget what y was, press alpha 1 for y, press math, choose option 1 to convert to fraction, press enter, and there's the 5 halves exactly.